Okay, so today we're going to look at matrices on the calculator. Now, some of you may have already figured this out, and that's fine. The goal was to really try to give you a sense of how it all worked, by hand before we kind of moved on to the more complicated stuff that will require technology to be able to help us figure out some of the answers. So I'm going to just go back to the first worksheet. I guess it was an optional worksheet that I posted was the matrix basics and operations worksheet, and that was an optional assignment. But I'm just going to pull a couple of matrices from there. I'm going to show you how to get these into the calculator and how to do some of the operations and inverses and determinants that we've been working with. So here's the way I like to do. I like to take this button right here. It's kind of next to this book down from the delete button, and it gives us a menu that looks like this. Now the first one that we're going to do is actually a 3 by 2 matrix. So you'll sort of notice that this kind of, if I click on this, it kind of gives us some standard ones. I don't actually want that, so I'm going to delete that. This would give us a 1 by 2 if we did that. And you'll see that there are some already pre-built ones. This one right here is the one that I use the most because it allows you to define the size or the order of the matrix as part of what it does. So if we double click on that, number of rows, number of columns, and again ours is a 3 by 2. So I'm going to ahead and put OK for that. And then just go ahead and start putting the numbers in. You can hit, kind of do that however you want. And I'd encourage you to kind of play along here. Put these guys in here as so. And again, this was question number 8 on that matrix operations worksheet. And then what we're going to do is we're actually going to store it into a variable location, kind of like we did when we were working with the financial math stuff. So let's see, I'm going to go ahead and store that into A, and it will allow us to do that. We're going to go ahead and make another matrix of the same size, a 3 by 2. And we're going to put in -1, 0, 4, 7, -3, and 2. And this is, from the worksheet, this is what we called matrix B. So we'll store that in for B. And the problem that went along with this, and this was not particularly complicated, but it was, we did 3 times A minus 2 times B. And that will give us the same answer as what we had there. And just notice that it's kind of doing that math for us. It's a scalar multiplication of 3, scalar multiplication of 2, and then subtracting those two. So you can do basic addition and subtraction. And again, I think as we saw there, the addition and subtraction was not, particularly difficult. It was, essentially just arithmetic. Now, some of the newer stuff that we did towards the end of the week with the multiplication and whatnot, that was a little bit more involved. So I want us to just kind of define a couple of other matrices here. We're going to go ahead and put in a 2 by 2. Kind of predefined to be that size, to -3, let's do 5 and 6 here. And we're going to go ahead and store that in as matrix C. I'm going to put another one in that's a 3 by 3. Now we have not done a ton with 3 by 3s because, particularly for the multiplication, it gets a little bit tedious. Make it easy here. We're going to store that in as D. And again, you can pause whenever you need to and kind of get caught up here. I'm kind of going through this relatively quickly with the inputs, I guess. So that's, I guess that gives us D. All right, so here's a couple things that I wanted to look at. With the multiplication, if we took A times C, A times C, A is a 3 by 2 and C is a 2 by 2, so that would actually work. But if we just put in A, C, I don't think this actually works when you do it this way. Yeah, so I think what you need to do is put in A times C. So if we were multiplying matrix A and matrix C together, that would be the answer. Now, if we kind of notice the sizes of the matrices here, if we try to do C times A, where are we here? C is a 2 by 2 and A is a 3 by 2. So those middle numbers are not going to match up. So C times A should not be defined here. Yeah, so it only has 4 elements, so on and so forth. So it says it's a dimension error. And that's kind of like what we talked about by hand, that there are some that you just can't do because of you need to have the same number of elements in the rows and the columns there. Okay, so the calculator verifies that, and that's good. So you can do multiplication. The other thing I want to talk about is the determinants, and then the inverses. And so if you go into the menu here, you'll notice that there is actually one that's a matrix and vector menu. You can also create your matrices through here too. I like that button. It seems just a little bit quicker to me, but you can go back that way too. So menu and then matrix, you can create one here. But notice that the third one here is determinant. So if we were trying to define the determinant, let's say of C, we can just put that and C. And so the determinant of C is 27, and we probably maybe could have looked at that by hand first here. So 12 minus a negative 15, so 12 plus 15 is that 27. That actually works. I think you can just type it in as like just using like letters too, which probably for me is a little bit easier because I'm on a computer doing this, but that gives you the same thing. And then we can find the inverse of C as well. We just type in C, and then you have to use this caret button over here, C to the negative first power, which is kind of the notation for inverses. You'll notice that you kind of see that 27 down here in the denominators. It's reduced a little bit up here, but that would be the inverse of C. Let's try the same thing with D. Remember that D was this 3 by 3. Now remember that all square matrices actually have a determinant. Now we did not talk about determinants for 3 by 3s by hand because it's a little bit tedious. You know, kind of doing this virtual learning stuff, I thought maybe that was something we probably didn't need to talk about this year. But there is a nice kind of procedure for doing that. It is a little more complicated than this, but I thought we could rely on technology a little bit to kind of cut through that tediousness so that we can just kind of get to the good stuff. So the determinant of D is actually 0. Okay. And again, you can find the determinant of any 3 by 3 matrix, any square matrix. Now, the interesting thing that happens here, if we try to find the inverse of D, let me remember myself where that is. Oopsies, sorry. Do the inverse of D. Notice that we get this error statement that says it's a singular matrix. Okay, so the process of finding the inverse of a 3 by 3 is kind of related to this 2 by 2 stuff that we did by hand. And remember that you know, we had something that was 1 over the determinant of the matrix. That's how we found this. We talked about that, I think, on Friday's video. But the same kind of thing here is you'll get this idea that it's a singular matrix, which essentially means that that inverse does not exist. So we'll quit out of that. Let's do something a little bit different here. Let's actually take one and create something that doesn't have an inverse. Maybe we'll do this positive. So is that 12 and 12? We'll call that something else. So we saw this idea in the context of here. We can try to find the inverse of E. And you sort of get that same thing. That's a singular matrix. Okay, so a singular matrix is something a little bit different, but it is related to the fact that this, if we try to find the determinant of E, that's going to be 0. And again, same thing we kind of see up here with a 3 by 3. So generally speaking, you know, you can find determinants of other square matrices. Square meaning they have the same number of rows and columns. So I think that's about it. So with the technology stuff,